Hey everyone, welcome back to the channel. In today's video, we are diving deep into regularization technique used in training neural networks. And especially we'll be focusing on N1 and L2 regularization. I will explain what they are, why they are important, how to implement them in code. So before we get into L1 and L2 regularization, let's first understand why regularization is important in machine learning, and especially the neural networks. When we train our neural networks, we are essentially trying to find the best weight for the model. But here's the problem. If we make the model too complex, it can lead to overfitting, where the model performs great on training data but poorly on unseen data. So overfitting happens when the model learns the noise in the training data instead of generalizing the pattern. And there's where regularization comes in. So regularization adds a penalty to the loss function during training, encouraging the model to keep the weight small and simple. This helps the networks focus on learning more general patterns rather than fitting to every single detail of the data. Now let's talk about the L1 and L2 regularization. So L1 regularizations add a penalty terms to the loss function based on the absolute value of the weight. This is known as L1 norm. And the formula for L1 regularization looks like this. Here the lambda is the hyperparameters. So this is the hyperparameter that control the strength of regularization, and the sum of the absolute value of all the weight is calculated. The key property of L1 regularization is that it increases the sparsity in the weight. This means that many of the weight may end up being exactly zero, effectively removing certain features from the model. This is particularly useful for feature selection. Next is the L2 regularization. So on the other hand, the L2 regularization sets a penalty term based on the square of the weight. And this is called L2 norms. The formula for L2 regularization looks like this. And here you can see we are squaring the weights with penalty larger, so which penalize larger value more heavily. This encourages the model to keep the weights small, but does not necessarily push them to zero. So L2 regularization tends to distribute the penalty evenly across all the weights. So it does not lead to sparsity, unlike L1. Instead, it keeps the weights small, reducing their impact and making the model more general. Now let's move into the code. So after loading the libraries, let's load the iris dataset. And so this is for the binary classification. We are selecting only two classes, and we are splitting the data sets here, and we are standardizing the features. Now let's start with the implementing L2 regularization. We'll create a simple neural network for classification. So here we have defined a simple neural network with two hidden layers. Uh, each dense layer has a kernel regularization argument where we specify the L2 with a value of 0.01. So we compiled and fit the model which ran, and now let's do the same thing for L1 regularization. So if I come down, run this. So here, as you can see, I've used the L1 regularization. So this will penalize the absolute value of the weight and encourage sparsity in the model for L1. Now let's compare the weights after training L1 and L2 regularization by plotting them. So if I scroll down, these are the weights from the layers, and let's plot them. So here we extracted the weight from the first layer for both models and plotted their distribution. The graph on the left shows the weight after training the L2 regularization. As you can see, the weights are generally smaller and spread out because they are not zero. On the other hand, the uh, graph on the right hand shows the weights that trained after the L1 regularization. As you can see, many weights are exactly zero, which shows the L1 regularization increased sparsity. So what's the difference in practice between L1 and L2 regularization? As we can see, L1 tend to produce sparse model where L2 keeps weight smaller but not necessarily zero. So in some cases, you may want to combine both L1 and L2 regularization, which is known as elastic net. And this gives you the benefit of both the method, sparsity from L1 and small weight from L2. And to summarize, the L1 and L2 regularization are powerful techniques to help prevent overfitting in neural networks by adding penalty terms to the loss function. And one encourages this sparsity while L2 increases small weights. You can experiment both in your model and depend on the task at hand. Thank you for that's all for today. Thank you for watching. I will see you in the next one.